Welcome to Precalculus Concept 23E under angles and radian measure. We are going to find the length of a circular arc. Woohoo! 3 boxes. So hopefully you remember that the way that we measure a radian, an angle radian, is by taking the distance around the circle that you've covered and dividing it by the radius of the circle. And so you may recall that when you have traveled exactly the same distance on the circle as the radius, then you have created what is known as 1 radian right there. That angle represents 1 radian. So in general, any distance that you travel around the circle divided by the radius is how we measure a radian. So let's go ahead and work with this algebraically. If the angle measured in radians is defined as the distance around the arc of the circle divided by its radius, then I can go ahead and solve this little equation for s just by multiplying both sides by r, canceling out. So s is then equal to r times theta. This is really important. This basically says that the length of the arc of the circle is just simply the radius multiplied by the angle that you've created. But this only works. This is a huge warning, and many students don't ever, they accidentally make the same mistake over and over again. This only works when theta is a radian. And I know that seems really simple and silly right now, but the reason this works is because this is the definition of radian measure, not degree measure. So it only works if this is a radian. So please be very careful in that. I'm going to show you some examples of how to avoid that. But this is what we're going to be working with, and let's move on. Okay, here's a really sort of classic example of the first thing that you do when you learn this stuff. It says a circle has a radius of 10 inches. Okay, I can do that. So I have a circle here, and I'm going to draw, and I'm going to say that this is a 10-inch radius. Okay, it says find the length of the arc intercepted by a central angle of 120 degrees. So where is 120 degrees? Well, if I was to go straight up, that would be 90 degrees. So 120 degrees is like 30 degrees past that. So here is the angle that I have created here. So there's an angle, theta equal to 120 degrees. So the question is, what is this distance that we have covered? How much have we covered? Okay, that's what we're looking for. It says find the length of the arc intercepted by the angle of 120 degrees. So here's where that classic mistake can come into play, all right? We know the following. We know that s, which is the distance that we're looking for, is equal to r times theta. But I told you in box 1 that theta only works, or this formula only works if theta is measured in radians. So before you have to do anything, you have to take 120 degrees and you need to convert it into a radian. And we do that by multiplying by pi over 180 degrees. So you get 120 multiplied by pi divided by 180, cancel out. This becomes 2 pi over 3. Okay, cool. So now I have a radian measure for the equivalent degree measure. Now that I have that, I can plug it into the formula and continue. So the s is equal to the radius, which I know is 10 inches, multiplied by 2 pi over 3. So s is going to be 10 times 2 pi is 20 thirds times pi. Now you can leave it as that, 20 pi over 3 or 20 thirds pi inches, or you could go ahead and then actually calculate that out to 2 degrees if you wanted to. So just take 20 and then multiply it by pi, push enter, and then divide by 3 and push enter. So this thing has traveled 20.94 inches all the way around, okay? So this is or approximately 20.94 inches. Depending on what the book wants, I'm fine with either answer. So this distance here is 20.94 inches. A very cool formula, but again, only works when theta is in radians. Okay, here you go. Here's a you try. Find the length of s in the picture. Notice you have a 45-degree angle measure and you have a 6-inch radius on this circle. Okay, hopefully got the right answer. So I did s equals r theta. I then took my 45 degrees and converted it into a radian by multiplying by pi over 180. That gave me pi over 4, plugged it back into the formula. So s is equal to 6 times pi over 4, so that's 3 pi over 2, or approximately 4.71 inches. Again, depending on what the book wants, if it wants the answer in terms of pi, you would simply say 3 pi over 2. If it says rounded to 3 decimal places, whatever, then you'd go to here. And there you go.